Due to the very basics of engines, and generally I give an example about the fundamental requirement of an human beings. If we look at ourselves, we find that we need food, some liquid, and what else? Some air. If I specify the quantity, even then you can get an idea that liquid I may require maybe 3 to 4 liter per day. Food may be 1 kg or 1.5 kg, including breakfast, lunch and dinner. And next is air. Do you know how much air we need? You may find this question is little bit difficult. And if I ask that without food we can survive 4 days, our engine can work, our system can work. Without liquid also we can survive for weeks, and without air we cannot survive even more than few minutes. From this I conclude that air is more basic requirement and more fundamental requirement, because I can't survive without this. Similarly, an internal combustion engine, which is being used in all motorcycle, scooter, cars, buses and trucks, their fundamental requirement is fuel, that is source of energy. Like here we are taking food, maybe paratha, rice, rajma, anything. There we are taking a chemical energy in the form of diesel or petrol or CNG or LPG, any source we can use. And another thing I need, that is a air. Like we have explained, for a human body the most fundamental requirement is air. Similarly, if you want to shut off an engine, you just put a hand on the intake system, immediately it will die, it will switch off. So more fundamental requirement is air in the case of engine also, like a human body. It means the oxidation process, the combustion process which is taking place, that is due to the oxygen which is present in the air. Now if I take you little bit 120 years before, when the first internal combustion engine was invented and it was used on the vehicle, at that time everybody was very excited and everybody was very happy. Do you know why? At that time, when this engine was fitted in a first horseless carriage in the city of London, the people were happy and they thought they have get rid from the pollution which was created at that time by the wastage of horses, because horses was the main source of the propulsion. And the wastage of horses, the lying on the streets, big heaps, so that is giving a stringent smell, because it is not one horse, 1,000 horses were there on the street of the cities. And that engine was developing only 7 horsepower and the size of engine was 4 liter. Today 1 liter engine can develop 70 horsepower. It means we have improved the efficiency of the engines by 10 times since then. How it has been done? What is engine management system? We would like to understand today in this discussion. Now, as we have discussed that most fundamental requirement is air. Let me understand the composition of air. Air is composed of, by volume, around 21% of oxygen and around 78% of nitrogen. You know, oxygen is necessary for the oxidation. Even when I am breathing, I am utilizing the content of the oxygen, which is around 21% in the air. Nitrogen is an inert gas, and there are other traces which are less than 1%, like argon, CO2 and all that we are not focused at this moment. Let me understand there are two main constituents of the air: 21% oxygen, 78% nitrogen. And this air combined with the hydrocarbon, we have to understand whether it is petrol, either it is diesel, either it is CNG. Like CNG is very easy, very simple gas. The composition is like 80% is methane. And methane, if I go by the chemical formula, it is CH4. It means any fuel, either it is petrol, or it is diesel, or it is biodiesel, or it is LPG, or it is CNG, it is a composition of hydrocarbons. Means carbon and hydrogen atom. And what we are taking also, carbohydrate. When these carbohydrates are burning, they are bound to produce CO2. Similarly, as I exhale, if I take the composition, CO2 is more. Similarly, when the engine is giving the exhaust gases, there is a CO2 in that. But CO2 will be there if the complete combustion has taken place. If there is an incomplete combustion, then there may be CO formation also. There may be unburnt hydrocarbons also. That we will discuss in the subsequent slides. So generally when I am talking about an engine, suppose I have a 1 liter engine, what it means? Some car manufacturers say 800 cc engine, some say 1000 cc engine or 1 liter. Hero motorcycle say 1000 cc engine. You know all this? But what it means? What it means 100 cc? What it means 800 cc? What it means 1 liter engine? What it means 2 liter engine? So today, even I am trying to mention what it means engine capacity. 800 cc means the engine can suck a volume of 800 cc amount of air which it can breathe into the combustion chamber. The displacement volume, when the piston is moving from the top to bottom dead center, it can suck around 800 cc of air by volume. It means 2 liter engine will consume more air. More air means more power, because it can oxidize more fuel. Another doubt I am clearing, that when you want to increase the power, it is not necessary and you cannot do by giving more fuel. Suppose I want you to, give me more power. Do you take more food? You have to take that much only. But if I ask you, okay, now run fast. So what is changing? You are taking more air. right? So I am taking more air. I am not taking more food. So whenever the engine is working, it needs more air. Proportionately, I have to decrease the quantity of fuel also. But paramount importance is air. So now it is clear what do you mean by 100 cc, 500 cc and 1000 cc. Higher the capacity, more the amount of air engine can take and more the power it can produce. Now, during our calculations of engine management system, what we are talking about, we are calculating how much amount of air the engine has taken. Because if I know that correctly, then I will calculate what is the amount of fuel I need to inject. And for this calculations, I have to calculate the mass of air. And mass of the air is equal to volume of the air into density. So density we are using around 1.18 kilogram per cubic meter. Some vapors are also there. So those at this moment we are not considering. Now next what is there? Air is there, fundamental. Next we are talking about any hydrocarbons and we call it a fuel. So any fuel, any substance, any chemical composition which can be converted from its chemical energy into heat energy, we can use that fuel. Do you know the first engine which was tried, they used coal, not steam engine, even in compression ignition engines. The coal was powdered very finely and that was injected into the engine. Because at that time petrol and diesel were not known. And if you go to the era, earlier we were using solid fuels. There are three categories of fuels. Solid fuels, that is coal and wood. Then there we feel it is giving a lot of smoke, lot of pollution and lot of waste. Because when you will burn coal, there is a lot of ash. Then they thought how we can clean the environment, and then comes the liquid fuels. Petrol, diesel, kerosene, these are the category of liquid fuel. Definitely as compared to wood and coal, liquid burning is more cleaner. And now why CNG has started in the engines? Why in Delhi Supreme Court has ordered, okay, all the buses, all the public transport playing on roads in Delhi, that should be fitted only with CNG. Why? Because it is a clean fuel. By nature it is a clean fuel. So solids are creating more pollution, liquids are creating less as compared to solid, and gaseous fuels are creating much lesser pollutants as compared to liquid and solids. Of course, you take any fuel, it is a combination of carbon and hydrogen. Generally, the percentage of carbon and hydrogen, it varies. In petrol it is different. In CNG, say CH4. So one atom of carbon is and 4 atom of hydrogen. So basically these two are conventional fuel. Most of your 90%, 95% vehicles are running on petrol and diesel. So we call it conventional fuels. But to reduce the pollution, to clean the environment, some unconventional fuels are also being used. And one of that is CNG, compressed natural gas. The chemical composition of CNG is more than 80%. It is methane, CH4. Now, very important aspect, very important aspect. That is, if you want to be healthy, if you want to optimize yourself properly, suppose every day you are taking 3 chapati and some salad, and if I ask you take 10 chapati, will you get more power? No. Even your system may have some problem. You may get some problem. If I ask you take half chapati, again you may have some problem. The important aspect in engineering and even in human health, it is what is the appropriate quantity which you should take. It is easy to take less, it is easy to take more, but the appropriate, because you don't know what is appropriate. Similarly, air fuel ratio, it will tell you for a given amount of air, you calculate how much fuel is required. If you are giving less than that, it may cause problem. That again we have to understand what type of problem it will cause. If you are giving more, again it will cause a problem. Like in a human body, if I am taking too much food, I have a problem. If I am taking too less fuel, too less food, again it may be a problem. So appropriate quantity, appropriate food, appropriate fuel is a design parameters which is very basic to get the maximum output from the engine, maximum output from your body, maximum efficiency of your body, maximum efficiency from the engine with minimum pollution. Here again I am defining, if you are taking more food, we call it rich. You are taking rich food. If I am taking less, it is lean. In engine also, I am correlating these aspects so that it gets into your memory. So whenever you feel, oh, after when I have taken rich food, which means you have taken more food, more energy. If I am giving, suppose I am taking 1 kilogram of fuel, how much air is required to complete the combustion? That we call it stoichiometric air fuel ratio. Stoichiometric air fuel ratio means if I am using 1 unit of fuel, either it may be in gram, either it may be in kg, unit 1 unit of fuel, I need how much air, or for 1 unit of air, how much fuel can be used. This is called air fuel ratio, and it is a very important aspect. And we call it stoichiometric air fuel ratio. So what is stoichiometric air fuel ratio? To burn 1 kilogram of fuel, how much air you need so that the combustion is completed. That is a chemical equation. For CH4, I can make CH4 plus O2 will produce CO2 plus H2O. So by chemical formulas, I can calculate how much amount of air we need for a particular fuel. And this quantity of air requirement will be different for different fuel. If I am using methane, it will be approximately, I am guiding you, it is 17 times more. If to burn 1 kg of CNG, I need 17 kilogram of air. To burn 1 kg of petrol, I need 14.7 kilogram of air. This is known as air fuel ratio. And if I am using the calculated stoichiometric air fuel ratio, it is chemically ideally required. Actually, how much is going to the engine? That is a different aspect. Chemically, it should go 14.7 in petrol engine. Now let's see how much it is going. If it is going more fuel, less air, we call it rich mixture. If fuel is less, air is more, we call it lean mixture. So there are three definitions now. One is stoichiometric air-fuel ratio. Another is chemically correct, which is stoichiometric. If air is more, we call it lean mixture. If air is less, fuel is more, we call it rich mixture. And the ratio of the actual air fuel ratio and to the stoichiometric air fuel ratio is known as lambda. Because in this lambda sensor we are using in the engine management system, so I am giving you the background. What is lambda? Lambda is, suppose chemically I have calculated, okay, to burn 1 kg of fuel I need a ratio of 14.7:1. So 14.7 is the air, 1 kg is the gasoline. Now if it is 15, so actual is on the upper side, so lambda is equal to 15 divided by 14.7, so the value will be more than 1, so we call it lean. The lambda value is 1.1, say 1.01 or whatever it may be. And if air fuel ratio actual is less, it need 14.7, but it is 13, so it will be 13 divided by 14.7, so that will be less than 1. So either the value will be more than 1, or it will be less than 1, or it will be 1. If it is 1, we call it stoichiometric. And 1 by lambda is equal to equivalence ratio. It is reciprocal of lambda. We call it fuel air ratio divided by fuel air ratio, but anyone will do for you. Now all struggle is going on how to control the air and fuel ratio. So this is one aspect of the mixture preparation. Suppose I am taking 50 cc of air. How much I know if I am to give 3 cc of fuel, how I give 3 cc? Neither 3.1, neither 2.9. How to make sure? And that too because the engine is varying speed and load conditions. The condition is changing. So as soon as the condition is changing, I have to change the quantity of fuel also, because air will change. And in running condition, to change it, air is going high, low, high, low. The fuel is also to match with that requirement. If I am able to do with 100% efficiency, it will be good. If I am not able to do, your fuel economy of your engine will be poor. Your pollution will be more. Waste of energy will be more. So now I think three things are clear. Stoichiometric air fuel ratio, where lambda is 1. Rich air fuel ratio, where lambda is, and lean, it is more than 1. Now I am giving some air fuel ratio of different fuels here. For petrol, it is around 14.7. For diesel, it is 14.5. For propane, it is 15.6. For methane, that is CNG, it is 17.2. For hydrogen, a wonderful fuel. Why it is a wonderful fuel? It do not have a carbon content, only hydrogen. So you will not produce CO2. So there is no carbon. So that is a fuel of the future. Even in the aircraft, when you are going there, so you are using some this type of concept, but that can be used up to certain level. But for oxidation, you need oxygen. But where is the oxygen? So either there is a carrier of the oxygen in cylinder we have to carry, and one cylinder of hydrogen, one cylinder of oxygen, because air is not available there. space application. And secondly, hydrogen is a very high calorific value. It is 3 times more than the petrol and diesel. 1 kg of hydrogen has around 120 megajoules of energy, whereas 1 liter of petrol has only 42 megajoules of energy. So energy content is more. So ethanol, we are using ethanol also, and we are using methanol also. Now, why it is so important? We should understand why it is so important to control the air fuel ratio. Why we are talking about so much? Okay, if it is lean, it is there. What happens if it is lean? What happens if it is rich? What happens if it is stoichiometric? I should know. I should understand that. Now these are the two curves. Wind is indicating about the power output of the engine. You can see the upper curve is the power output, okay, and bottom curve is given the specific fuel consumption. Now if you look at where is the maximum power you are getting, around 12.4, it means here mixture is rich. If I use same mixture, so my fuel consumption is higher, but I want fuel consumption should be low. If I am making it lean, at stoichiometric air fuel ratio around 14.7, the fuel consumption is reducing, but it is not to the minimum level. Minimum fuel consumption I am getting around 16:1. But if I am using the 16:1, I am getting very fuel economy, but I am not getting the power. And that is a challenge. And that's why engine management system is coming into picture to manage all this scene. Now I have shown you one slide only where the power and fuel consumption. What about emissions? Emissions is also a challenging task. I have to reduce the emissions also. Now we can see the effect on the emissions also. To understand the emissions, let me make you clear the fundamentals of combustion. Why I am trying to get the stoichiometric, what happened? Because ultimately I am burning the fuel. Burning rate, what happened to the burning rate? If you see, the dark line, bottom line is the flame speed. The flame produced in the petrol with which the combustion can take place. So maximum flame speed is around rich mixture. It means petrol can burn very quickly when the mixture is slightly rich. If you will make it 10, no, not good. If you are making it 18, not good from combustion point of view. So flame speed is maximum around 13.8 air fuel ratio. There your combustion is very fast. It means that like you take some tonic, but 10% tonic will do. If you take 50% tonic, it will not do. So here with the engine also, little tonic, little extra fuel will make your combustion better, will make your power better. Clear? Now, this is all three. It means if you see, what is the challenge to me? If I want to get the very good combustion, I need different air fuel ratio. If I want to get maximum power, I need different air fuel ratio. If I want to get maximum fuel economy, I need different air fuel ratio, and they are contradicting each other. So as an engineer, as a scientist, as a technical expert, what should I do? Whether I should operate at the upper one, middle one, or lower one. That is a challenge. Now this we have make it clear the basic three things. Now let's come to the emissions. There are CO, there is HC, and there is NOx emission. Now if you look at the NOx emission, NOx is maximum, it is a bell shape. NOx is maximum when lambda is 1 or air fuel ratio is 14:1, 14:7. If I am operating very close to stoichiometric, so NOx emission will be very high. That is a problem. If hydrocarbon, if you see, as I make the mixture rich, hydrocarbon emissions is going up. If I am making lean also, again it is going up. So hydrocarbon emissions, if I want to reduce, I have to play around 40.8 or 14.9. But if I am operating there, NOx is maximum. मैं क्या करूं? Because I have to regulate both. Emissions regulations say NOx should be also low, hydrocarbon emissions should be also low. Let's come to the third, CO emissions. If I am using a rich mixture, CO is very high. So if I want to increase the power, it means hydrocarbon will go up slightly, CO will go up. If I am making it lean, power will reduce, but again hydrocarbon will increase, fuel economy will improve, and CO will reduce. So for CO, from this trend I see that lean mixture is good for CO reduction. Why it is good, we will cover it tomorrow in combustion study. Hydrocarbon emissions, if I want to reduce, so I can operate the engine very close to stoichiometric, around 14.7, 15, in that range. But there NOx is very high. If I want to reduce the NOx, either I can operate rich or I can operate lean. So it means for CO it is different issue, for HC it is different air fuel ratio requirement, and for NOx it is different. Now I have 6 parameters, or for your understanding let's say 5 parameters. I want power, I want fuel economy. Air fuel ratio requirement for power is different, for fuel economy is different, for CO it is different, for hydrocarbon it is different, and for NOx it is different. So there are 5 things which I have to control, and all the 5 things are requiring different type of air fuel ratio. So how to manage all these things? You need something else, you need something else, you need something else, you need something else. Suppose you are CO, you are HC, you are NOx, you are fuel economy, you are power. So everybody say I need this, and I need all optimum for a good engine. So this challenge is identified, and people thought how to meet this requirement. So we are going to talk about this in this series. Earlier, to meet the air and fuel ratio requirement, we were using carburetor. You know carburetor? The first engine, when it was designed in 1900, it was using the carburetor. And since then, there were a lot of modifications in the carburetor were done. So, if air is 1 kilogram, how much fuel is to be given, that was controlled by the carburetor. So carburetor is a device which was metering the air and which was mixing the appropriate quantity of fuel into the air. So that was done like that. Even today motorcycle engines, most of the motorcycle engines, they are working with the carburetor. Why? But today no car is using carburetor. Carburetor is obsoleted in 2000 because it was not able to meet the emissions. It was not able to reduce the emissions beyond Euro 2. Up to Euro 1 it was good. It can meet Euro 1 or Bharat stage 1. But then they say, okay, you reduce CO further, you reduce HC further, you reduce NOx further. Carburetor was not able to meet. Then what to do? Why it was not able to do? Because carburetor was not able to control the air and fuel ratio very accurately, very precisely it was not able to do. And hence the system like electronic fuel injection system was introduced. And today we will talk about this system. In fuel injection system, there are different type of options are available. We have single point injection system where we are using only one injector. We have throttle body injection system. We are using injecting in the throttle body itself. We are using central fuel injection CFI. We are using port MPI multi-point injection system. Suppose there is a 3-cylinder engine, so we are using one cylinder for in every cylinder we are using one injector to inject the fuel. Then GDI, it is a new concept. In India, there is no car which is using GDI, but some car has been tried. It is a gasoline direct injection system. Here the injector is mounted directly into the combustion chamber. So it is a more complicated, we will touch upon this, but today our focus will be to understand the fundamental of the mixture preparation. That is, one part is carburation. Little bit I give the background, what is a carburetor, I have given you little bit, and then why carburetor is obsoleted and why we have introduced the fuel injection technology. You see, just because it is history, we should know our parents, our grandparents' name. It is like that. So in technology also we should know what was there and how it was improved. Earlier we were using single barrel carburetor. So there was one passage only from where air was coming and fuel was injected there. The problem is engine is working, or it is bound to work under a wide range of speed and load. When you start the engine, it is known as idling. It is running at 900 RPM. When you accelerate, put first gear, you are accelerating maybe 1200, maybe 2000. Change the gear. If you are on the highway running at a 90 km/h speed, the engine speed may be 4000 RPM. Load is varying, engine speed is varying. So that one barrel only was not able to meet the varying requirement of the engine air and fuel. Then what they thought, that we can use double barrel. Like this, there are 2 ports has been submitted. So that gives little bit better performance, but again it was not optimized. Why it was not able to meet the requirement? Because there is a fixed jet which is giving the petrol. So the fixed jet can give the fixed amount of fuel at that particular speed. It cannot vary. The jet size is fixed and you have put in the carburetor. The jet size may be 1 mm, jet size may be 1.2 mm. So that may be good at 2000 RPM, but that may not be good at 4000 RPM. So I cannot meet the requirement under all conditions. Now, second more important thing is when you start the engine in the morning, because carburetor is using a pressure delta P. What is the difference between the atmosphere pressure and in the carburetor at the throttle, where this venturi is there? Here pressure drops and fuel comes from this to the venturi. Here the pressure difference delta P is very low. So when you are starting the engine, the fuel atomization is poor, because the fuel is liquid here. When it is coming here, it is coming in drops. If drop is very fine, the diameter of the drop is very fine, very fine, it will mix in the air very well. Like if you have a big cube of sugar, it is difficult to mix in the milk or water. But if you have very fine powder, it is quickly you can mix it. So, and this problem is more prone at low speed. At high speed, speed is very high. So if you mix, it can mix up. But at low speed, it is not mixing. So that was one problem with the carburetor. Poor atomization, we can call it technically. Due to poor atomization, idling was unstable. Engine, suppose you want to fix 900 RPM. So sometimes it is going 950, sometimes 850, sometimes 1000. You are not changing anything, but still engine is changing its speed because of this behavior, which is not good for fuel economy point of view, neither it is good for the efficiency point of view, and nor from emissions point of view. Now another important thing, I am giving a figure per cycle per cylinder. Typical 800cc, like this is the example of Maruti 800cc car or Alto 800cc, that need only 3 gram of fuel per cycle per cylinder. Only 3 milligram. 3 milligram. To meter 3 milligram, it becomes 2.9 or 3.1. Your stoichiometric equation has changed. Your air fuel ratio has changed drastically. So I have calculated, okay, I have a carburetor, please give me 3 milligram. But carburetor, sometimes it is giving 2.8, sometimes it is giving 3.2, sometimes it may be giving 3 also, but it is not giving constant. So my efficiency, my pollution is going in a different direction.
Carburetor works on a speed up. Speed भी change होगी सर उतना fuel consumption होगा.
नहीं, speed change होगी तो engine की speed, if speed is increasing, more amount of air is coming in and more fuel will come. That is met by carburetor. That is taken here. But the problem is that size is same. So it may come, it will increase, but it may not increase appropriately, which is required by the engine. That is the problem. There is a little bit slag in that. Now, another thing, if carburetor is 1 and if I have 3-cylinder engine, so that same fuel is going through the intake manifold, right? So we call it mixed distribution. The fuel going, because I have put in the center. Now there are 3 cylinders like this. One is here, one is here, one is here, and fuel has traveled to this. In the center, it has a shorter path, and it has a longer path. Even if you give the same quantity of fuel, but when reaching to the combustion chamber, it may be different because the traveling distance is different. It may stuck on the walls also, the intake manifold. So mixed distribution is not uniform. Clear? Now one important aspect also I am telling you, during highway driving conditions, suppose I am running at a speed of 80 km. I am driving. Due to any reason, I have seen, okay, there is some traffic problem, I have to reduce my speed. So what I will do, I will remove the foot from the accelerator pedal. My throttle position will become 0. But car is still running, it will not come down immediately. Suppose it is after, I have to stop after 2 km. This period we call it deceleration period. When I want to retard the speed of the engine. Now when I want to retard the engine, so 90 the vehicle is running, it will come at 85, 84, 80 like that, right? During that time I want to reduce the speed, but fuel is still going to the engine. Carburetor will give the fuel. Okay, but I don't need fuel at that time. It may be possible I may be applying brake also, but fuel is still going. So this concept is known as fuel cut-off, because I don't need, so I say, okay, I don't need fuel. Cut off the fuel supply during this period from the carburetor. That is very difficult and even not precisely possible. That is again a limitation of the carburetor. In injection system I can do it, because I will give the command to the ECU. I will develop a strategy in the control strategy. Okay, when the deceleration is there, you cut off the fuel. I cut off the injector. There is no supply to the injector. So injector will close, it will not open, no supply. And even I can make a strategy when I need again the fuel. Suppose I need at 30 km/h speed. Again I want to accelerate. Again it will start automatically. So that is there. So I think now you are better acquainted why air fuel ratio has a significant impact on the power fuel consumption, on the power, on the engine emissions characteristics like flame speed, flame temperature and combustion pressures, and at the same time emissions also. So with this it means you can realize, it means there is a need to control the air and fuel ratio very accurately, very precisely. This is a very simple throttle body injection system. In this there is a throttle body, and instead of carburetor I am using a injector. This injector is mounted in the central part of the throttle body, where you can see the spray. Spray is taken place in the throttle body itself. So injector is located just above the throttle valve in the throttle body. This system operates at low pressure, around 1 bar. Therefore, fuel metering at lower cost due to inexpensive fuel pump. So in this system we don't require fuel pump. The pressure difference, only what I have done, located an injector in the throttle body. So instead of that jet, I have replaced that jet with a injector, which is controlled by the current. Now we have covered one part, fuel. Now only if I am giving the fuel, how to start the combustion, that is another part. That part is, it means I have to create a spark at the appropriate time. How to do that, when to do that, what should be the duration, and what should be the energy of the spark so that it can create the combustion. Earlier the system, what we call the contact breaker type, there the limitation is that we have the breaker mechanical point and the current is passing through that. There was ignition coil. When it is opening, the secondary voltage is produced, that is around 15,000 volts and like that, because it is a ignition coil, it is like a transformer. There is a primary winding, there is a secondary winding, but that interruption is done by the mechanical breaker point. That's why if you go for the tuning, they set the mechanical point, and when it is opening, little spark is created. So to avoid that damage, we are limited. We cannot increase the primary current. Hence our secondary voltage is produced always not what we want. It is less. So that was the limitation of the mechanical type of basic ignition system. And to burn the fuel properly, completely, we need appropriate amount of ignition energy. Secondly, that mechanical point, after sometimes after 20,000, after 10,000 km of running, that pitting starts and the performance further reduces. So this secondary voltage production is reduced, the output is not sustainable, not stable over the period of time. That was the problem of the ignition system. But I need fuel, air and fuel ratio, and I need the ignition system to burn that. So that is another part. So earlier we were using the basic ignition system. Now engine management system will also control the ignition timing and ignition energy. So the engine management system not only control the amount of fuel to be injected, but amount of ignition energy and time of ignition. So this is what we call engine management system, and how it is done, that we will discuss. Now why all this has been done, if you look at the emission, just to give a background, Bharat stage 1, we call it BS1 or Euro 1. CO was 2.72 gram per kilometer. Euro 2 was reduced to 2.2, and in BS4 it is 1. Similarly, HC is reduced and NOx is also reduced. So this pressure on the emissions reduction carburetor cannot do. So that's why we need a. Now I will start the engine management system. Now this system can be categorized into 4 parts. Air intake system, where air is coming. Fuel delivery system, fuel is coming. Different sensors and engine control module, that is the ECU. Now look at the air intake system. You can understand it is like a nose. I am inhaling from here. So, even in our nose, there is a filter system is working, which will hold all the dust of the air. There are small fibers inside the nose. So they remove that dust. Here we are using an air cleaner, which clean the air and before going to the engine. So we call it air filter. Then from air filter, the air is passing through the throttle body, and if engine is supercharged or turbocharged, then it will pass through that also. Otherwise it is going to the engine. So intake system comprises of the air filter and throttle body. Now air filter, why we want to use air filter? So that if dirty air will go, it will damage the engine. The life wear and tear will be very high and engine will seize. It will damp the noise also. If you remove the air cleaner, noise will increase. That is also another benefit. But if I am using a air cleaner, I have to clean it after some time because dirt will be there. So when I should clean it, how much dust it can hold, that is a design parameter. That we call it dust holding capacity. How much dust it can absorb. In new filter, the pressure drop, because whenever we are putting any filter, there will be a pressure drop across that. So that is around 1 kilopascal. And filtration efficiency is generally we keep more than 98%. So most of the dirt should be removed. Now there are different type of design. It is side mounted, central mounted, paper type of filter. We use filter papers to clean the air. And you have seen some oil bath type of filter also. Oil bath type of filters are used in buses and trucks where the dirt amount is very high, in tractors also. And paper type filter is used in motorcycle and in passenger cars. Now come to the throttle body. The throttle body actually controls the amount of air. Your accelerator pedal, when you are accelerating, that is controlled by amount of air is controlled by the throttle. You see, you can see that valve. Air is coming from the air cleaner side, then it is going to the engine. So this is the valve. So when it opens, more air is allowed. And generally, from your interest point of view, these throttle bodies are made of either of aluminium or of plastics. So it controls the amount of air. On the throttle body, we are mounting the throttle position sensor, which indicate how much throttle is opened, and it gives as a input to the ECU. We call it throttle position sensor. Now very interesting one thing, like suppose your car is at idling and you have switched on the AC. When you switch on the AC, you are not pressing the pedal, but load increases. So when load increases, who provides extra air and extra fuel? So for that, we are putting a idle air control valve, which is integrated in the throttle body only, or sometimes it is separate also. So whenever there is a load, extra load during idling, that is taken care by the idle air control system. This is idle control valve. So you need more air during idling. In this condition, throttle is constant. So there is a bypass. If you can see, there is a bypass. The valve will open and allow more or less air from the bypass. So that system works through the electronics, through the ECU, and that strategy, we have to develop that strategy. When to open, how much to open. So for this we can use two type of system. Either stepper motor we can use. So stepper motor, I give the current, it will open more and more steps. Or I can use, there is a flap type of valve that can also be used. So different company uses different type of valves. This is the duty ratio, how much airflow is required, and that is the duty ratio of this is idle air control valve. If it is open more duty, we call it more duty ratio. Means that if the capacity is 100%, it is working with 100% capacity, duty ratio is 100. If it is completely closed, 0 duty ratio. If it is 10%, it means utilization 10%. So it depends how much engine is required. I may open it 10%, 20%, 30%, depend upon the need of the engine. Now air intake system. So there is a air cleaner, throttle body, and idle speed control valve. Now come to the fuel delivery system. We have the fuel pump. Then we need fuel filter, like air filter. We have to clean the fuel. Then we need a fuel pressure regulator, because we want that fuel, what it should go to the injector, it should be at constant pressure. If the pressure will be varying, then the quantity which you are injecting, that will vary. So here I can give you experimental data. In cars, we use around 2.9 bar of pressure. Like Maruti Alto use 2.9 kg per centimeter square fuel pressure. So pressure regulator is giving the fuel at a constant pressure of 2.9. So fuel pump is working between 3 to 4 bar, then the pressure is maintained by the fuel filter cleans the fuel pressure regulator maintain the pressure of the fuel. Delivery pipe, suppose there are 3 cylinder injector, I have to mount 3 injector, so that we call it a delivery pipe or fuel rail. So this is the schematic. Fuel pump. Let me understand about the fuel pump requirement. It should be capable to work between -40 to 80 degrees Celsius. Now why it is so important, I tell you. The first car, this Hyundai has launched in India with injection system in 99. And when this car was launched with the electronic fuel injection system, there are many complaints. The car was standing on the roads. They are not, running. when they analyze what is the problem, you know what was the problem? The problem was, and they were working in Korea, Japan, everywhere, because the fuel pump was designed, it was working at a temperature of maximum up to 50 degrees Celsius. In India, summer is very hot and the temperature of the fuel tank goes above 50 degrees Celsius because the fuel is going to the engine then coming back, extra fuel. So that also increase the heat in the, and atmosphere temperature is supposed 46. It means it will increase there is no heat exchange, so it will increase. And if the temperature is going beyond 50, the fuel pump start malfunctioning. It don't works. So fuel is not going to the engine and vehicle stops. So that's why these specifications, that's why we have mentioned the pump should be capable to deliver the fuel from minus 40 to 80 degrees Celsius. Maintain the desired flow rate at rated voltage. Maintain fuel system pressure of 3 to 5 bar. And it should be capable to meet all type of vibrations in the vehicle, because when you are mounting in the vehicle, the tank, it is under vibrations. So under vibration it should be capable to deliver. Right. Now one more important I would like to tell you. Do you know where is the pump is mounted? Most of the people, sometimes you are sitting in a car, you might have driven a car. Do you know where this pump is mounted? Inside the वहाँ पे ना इंजन के साइड में we were mounting the fuel pump of a carbureted. You are right, the carburetor fuel pump are mounted near the engine there. It is a mechanically driven. But this pump is not mounted near the engine. You see why I am taking this example. You see, this is a very simple thing, right? But you know, sometimes we never think about all these things. We are using a car. Maybe I may be a mechanical engineer, I may be electronic engineer, or even I may be a customer of the car. I am a user of the car. You know, when we start in a different thinking mode, even thinking is an art. Most of the people, we don't know how to think. They say, suppose somebody don't know how to swim. So if you don't learn the swimming, you cannot swim. If you don't know the cycling, you can't cycle. If you don't know how to drive a car, you cannot drive. Even thinking is an art. Even apple was fall due to gravity on the earth. I think before Newton, everybody has seen that, no? Apple or mango or any fruit or anyone putting you anything from your, it is falling on the ground only. What was the big thing in that? Everybody has seen that. But Newton has think in a different way, right? Am I right? So it is observations. When we are sitting in a car, suppose I am traveling in a car, so I am idle at that time, or I am sitting in a bus even, CNG bus. So you can think about some concept also. So even in Japanese the system is, when we have learned in 1999 about this engine management system, the first question was just to identify the components where they are located. And you will be surprised, even among the faculty member, most of the faculty member, even today if we open a car, the car is standing there, and if I ask locate all the parts of the engine management system, we may not be able to do that. where the which part is located. Forget about the uski fundamentals and concept. Most of the people are not able to do that. So prerequisites, that is the difference between our education system and little bit Japanese or German education system. They are more practice and practical oriented. We are more theoretical based. We teach, okay, fuel pump, this, itna pressure, like that. So that's why, to break that concept, we give the example always. We try to demonstrate. So that's why this today test bench has been, I have bought this test bench so that I can show how this injector looks like, how the current sensories look like, what is TPS. It is a bird, it is an animal, it is a some electrical device, it is a mechanical device. You can feel, then you will be more confident about that. So this pump is mounted inside the fuel tank, and there is a very special requirement of this pump. Though the pump is mounted, it is electrical operated. If any spark is created, it may cause a blast. No, so it is, then one should think, oh, it is very dangerous also. And suppose, because always there will be some fuel in the fuel tank, but it cannot be mounted directly on the floor. There should be some gap, maybe 10 mm or 15 mm, so that it cannot suck the dirt. There is a filter also at the bottom end. If the fuel is lower than that, the fuel pump is not able to suck that. That is called dry operation. Even during designing a pump, we have to give the specification. If the car is empty, driver fuel gauge is not working, you don't know how much fuel is, and it stopped running the car. You don't know what is the problem, and there is suppose no fuel. What you will do? You will try to start the car. When you will try to start the car, as you switch on the ignition switch, the pump will work, but there is no fuel. It will start rotating, and at that time, the spark created in the armature and rotor, and because some fuel is always there in the tank, but pump is not able to lift that because it is at a very low level. That is very good. Or pump will short circuited. It may cause a blast. So we have a test known as dry operation test. If you run the pump without fuel, at least for 5 minutes, it should not give the spark. What we think, what is technology, what is this, what we learn and what we teach, we should go with the practical aspect of that. Even what size of wire we should use. Even if suppose you met an accident and car is tilted, and in accident your ignition is on always, right? Because you are driving and suddenly something happened. You are struggling with your life, you don't have time to switch off that. The pump is working still. Even that condition is also to be taken care. That we call is, and if car is inclined like this, car is rolling, we call it rollover switch is there. That will not allow any fuel to go outside the tank. That will not allow the fuel. It will cut off the fuel to the engine. It will, when the car is tilted and met with an accident. So there should not, because now car is not running, but engine is running. So it may cause some fire and all that. So what I want, that fuel should not go to the engine, right? So that provision as a designer I have to give for the safety of the people, for the safety of the passengers. So there are very, very minute things which we have to consider. This is the internal structure of the pump. It has a motor, assembly, and then check wall is there, relief wall is there. Now coming to the fuel filter, you know, now I am just discussing for few minutes for fuel filter, but there is a, you can do lot of PhD on fuel filter. What size of the paper should be there? What should be the pore size? Even new concept is coming in fuel filter, that is a nano fiber. Now we are using nano fiber to make the fuel filters, where the pressure drop should be minimum. If high quality of fuel you want to make, there should not be any dirt in that. Even nanoparticles should not be there. There are plants, there are companies who are working only on fuel filter only. So mean pore size is 8 to 12 micron of the this, and flow rate and efficiency of the fuel filter is generally 90%, but now they are demanding more. They say it should be 95, 98. So we have covered fuel filter, fuel pump. Now fuel pressure regulator. Fuel pressure regulator just try to maintain the pressure at a constant outlet pressure. Even if I want to talk on fuel pressure regulator, I can spend only 1 hour in that only. But our purpose is to have a look at the total and complete engine management system. So we may not go at the design aspect of each and everything. Delivery pipe is, you can see, it is a fuel rail where the injectors are mounted. This also in demo section we will show this to you. Now fuel injector. You will be surprised, in India there is, even as on date, no company who is making the fuel injector. It is such a precise technology and concept. Even no company is making engine management system. Now this injector making itself is a, all big shot can combine together and they can try to work on that. But simply if I am talking, okay, fuel injector, it is a solenoid valve. When I give the supply, it opens. When I open, fuel is injected for 3 milliseconds, for 4 milliseconds, for 10 milliseconds. And when I am not giving the supply, so this no. It means we think, oh, I know the fuel injector, but I know the function of this, the purpose of the injector. I do not know the design aspect of the injector. I do not know the features of the injectors. The hole which I am making it, that is even less than millimeters. So to make that hole, to make that assembly, this plant of this is a company called Denso Japan. They put the plant. If you will see that plant, you are not allowed to go inside that plant with your bare head, without goggles and without covering your body. Because if very nanoparticle is also wet during assembly, it goes inside the internal structure. It may spoil the performance of the injector. The people who are doing the assembly, if you will see that line, before that you have to pass 4 stages which are totally clean environment. First they will wash you with the clean air, then they will take you apron, complete cover your body, then they will cover your head, they will cover your eyes, they will give gloves also. After cleaning different stages, then you can enter there, and in entering there you cannot enter with the assembly. There is a glass, you can see from that outside. Nobody is allowed to. Your shoes, you have to, okay, shoes, basically you have to remove the shoes, you have to take their own internal, etc. So that type of precision is required. And you cannot see the operation of this injector with your naked eyes. I think in 20 seconds, 80 operations are done. The robotic which is moving, you can't track that, because you have to produce in millions. If, like in India, suppose we are producing around 20 lakhs cars. In each car average you are using 3 injector. 20 lakhs into 3, 60 lakhs every year. Precision. And this is only OE requirement, spare requirement, so maybe 10 millions. So when we are talking about this concept, so one is knowing the principles, second is implementing that principles. So even the question, okay, locate the injector in the car. So people are looking this, where is the injector? Locate the crank position sensor in the car. I am teaching in the institute, okay, this is a crank position sensor. If principle is Hall effect sensor is good. What is Hall effect? Okay, you may go through the theory, how it looks, what is the shape, where it is mounted, in which location it is mounted, in which environment it is working. When I am mounting the injector, when we are talking about the sensors, so the gap between the tooth wheel and sensor, it is in, very precisely controlled in 0.1 mm, zero point 0.9, 0.8, 1.1, and if there is a change in that, your performance may change, and if the gap is changed significantly, then you may not get the output signal even. Your car will stop because that is the most fundamental signal. If I am changing the tooth profile, how it affect that? So all these things will happen when. So this is a one exercise. I think, I don't know, in studio it is not possible, but sometimes if we have a we can take the participant near the car and we can give exercise. Okay, identify and locate each and every component of the engine management system, where it is located and why it is located there. So even identification is one exercise which may take few hours. So for fuel injector, the flow rates are very important. We have test bench to calculate the flow rate and all that. We measure the quantity of the fuel to be injected. We measure it in a time frame. There is spray angle. Again, there is a engineering in that, whether it should be 15 degree, 20 degree, 30 degree, 40 degree. Now, another point is when I should inject. It is a synchronous injection, asynchronous injection. This we will cover little bit, and it is timed injection. When I am cranking the car, I don't want that it should take injection at one time only. I want that during intake stroke it should occur at 3 times. Tick, tick, tick. And during running of the car, it should inject only once. At every stroke. So there are different strategies. When temperature is very low, because if I am injecting one time, the mixture preparation will not be good. So I have to give the dose at every certain millisecond. So these are the control strategy. Like start injection volume. It means when there are two basic things. One is the basic duration of injection. That is, I have given in a table calculated, but I have calculated under a certain controlled conditions. Suppose I have done at a temperature of 25 degrees Celsius, and when the car is driven, the temperature is 40 degrees Celsius. So how to compensate that? Or it is winter, 0 degrees Celsius. So air density will change. If air density will change, the fuel requirement will change. Fuel requirement will change. So we have to add the compensation for all these things. So first is the basic injection duration, and then I have to use the correction coefficient, which is different. You can just see this is the correction coefficient, start of injection duration, fixed. Correction coefficient depending upon the temperature, cranking, battery voltage reduces. It is not 12 volt, it may go to 10 volt. At that time also it will affect that electronics. So I have to compensate for that, and there may be many correction factors like this. I am just telling you the fundamentals of this. So my total injection duration will be basic duration of injection plus correction coefficient due to temperature, due to battery, due to humidity, due to altitude. I am going at Shimla. Now atmospheric pressure will reduce. How it will affect? I have fixed here when car was running, I was giving a duration of injection 3.5 millisecond. When I am at Shimla, should I give 3.5? No, sir. It will not work. If I have gone to Leh, it will not work. I have to give this. So there is a altitude compensation is there. You know that engine management system, it is such a typical subject and such a challenging that in the world there are 3 or 4 companies all over the world which are doing this. And not only in India, I think in India or in this region, no one is there. It is from Japan, it is from Germany, it is from USA, and it is from Europe, Italy. There are 4 companies broadly, so major player, because it requires the understanding of the engine, it requires the understanding of the sensors, actuators, software, hardware. So all these things are required. So these are the compensation which we are talking about. Correction and coefficient. During starting, what I should do. During warm up, what should I do. During temperature air correction, what should I do. Transient time, what should I do. If I need suddenly more power, what I should do. That is another enrichment. Air fuel is a feedback correction. Ideal stabilization. High altitude correction, which I am talking just now, and fuel cutoff during deceleration period, which I am talking. If the car is running at 100 km/h speed, you are suddenly deaccelerating, fuel should cut off completely. That strategy also will learn. And for how much time it should be cut off? Till 50 km, till 40 km cut off speed, vehicle speed, or 30. And you should not feel a jerk. So these transient conditions, they are very complicated. And you have to simulate that, you have to integrate all these things in your programming in the ECU. So these are different enrichments, warm-up enrichment and all that. Warm-up enrichment means when there is a cold, you can see coolant temperature, warm-up coefficient. So the value is more than 1, it means your duration of injection should increase. And when it completely warm up, it is multiplied by 1. 1 means basic is equal to 4.3 into 1. If I want to increase that, multiplication factor will be more than 1. So for all the correction factor, we are using in the same way. This is the temperature correction, transient time air fuel ratio correction. Power enrichment, again duration of injection increases when you need the more power. Now I am coming to the sensors. Fuel cutoff during deacceleration, I have just discussed this. So whenever deacceleration, first thing, now I have spoken you cut off fuel supply during deacceleration. But the first thing, how you identify this is a deacceleration. That is again a control strategy. How ECU knows the engine is now deacceleration mode and I should cut off it? Which type of signal I have to use? Which is giving precisely this information correctly? Another interesting thing, earlier, when you are pressing the accelerator pedal, engine will increase the speed. But there is a I say the engine should not go beyond 6000 RPM, otherwise it is dangerous. So in the ECU we are giving a provision, okay, if the RPM are above 6000, it will cut off the fuel supply. So engine cannot vary. If 6100, it just crosses, it will cut off, it will come down again. So that protection is there to the engine.